Hey everybody, this is the recording for 1.6. This is absolute value equations. So this is actually not a terrible section. What you will need to sort of bear in mind to do it though is that there are a couple of sort of standard practices here that we need to pay attention to as we work. Sorry, my slides are angry with me, so we're gonna give that a second. Nothing is going. Hold on. There we go. All right, now we have a pen that helps. Yeah, I just need to change color. Okay, everything's been slow today. So when we solve absolute value equations, come on, slides, help me. I might have to start this over. We'll give it one more second. Oh, there we go. Okay, so when we solve an absolute value equation, here's the thing. The absolute value equation is always in this form. This absolute value of x equals a is the standard form, and you're always aiming for this standard form, okay? If there's two things that can happen here. So first, if a is greater than or equal to 0, the solutions to the equations are given by x equals a and x equals negative a. There's two ways to solve it. It's like saying the absolute value of -5 is 5, right? If I got an answer of 5 here, in the absolute value sign, I could have put a -5, but I also could have put a +5. I have to account for both cases. If a is less than 0, every time you're in standard form, there is no solution, because here's the thing. I can't take an absolute value and get an answer that's -a. Like that's not possible. So we have to keep our eye out for that case so that we don't do way more work than we need to. All right, so straight off, this is a fairly straightforward example. Solve the absolute value equation. Think about the things that could go in for x. Well, I know that 5 is one of them. I know the other one that could work is -5, okay? In this case, we're going to solve this equation so that we get to the form absolute value of x equals a. So what I'm going to do first is add 2 to both sides. This is an important thing to keep in mind, because if you don't do that work first, then it makes everything a lot harder later. Once I get to the standard form, my answers are going to be w is 14, or w is also -14, both cases. The next slide is the absolute value of p equals 0. Technically, I can make this two cases. I could make it 0 and -0. But to be honest, like, I don't really need that -0, because like if I give you nothing or I give you -nothing, no matter what I did, I still gave you nothing. So we just have to consider the one case here. In this equation, the absolute value of x equals -6. Here's the thing. The absolute value of something can't equal a negative. So I'm not going to go through the exercise of writing 6 and -6 here, because this answer is impossible. So the answer here is no solution, empty set. We can't get to that, okay? Not possible. All right, so these are ones very similar to the examples we just did for you to try. Go try them, okay? All right, so now we want to solve these absolute value equations. There are two keys. The first is to get into standard form. Isolate the absolute value, write the equation as absolute value of x equals a, where a is a real number. When a is less than 0, there's no solution. Otherwise, rewrite the absolute value equation as x equals a or x equals -a. Those are the two key steps. Once you do that, you can solve. But here's the thing. You have to isolate, and you have to handle both cases. If you don't do one or two of those steps, it's not gonna work. So those are the two keys here, the things that you circle in your notes, the things that you write down 10 times, whatever it is you need to do to remember it. So here's the first example. So we're gonna look at this. It's already in standard form. I'm already in x equals a form. That's fine. So now I'm gonna make my two cases. The first case is just what I have here, 2w minus 3 equals 5. The other case, that's x equals a, absolute value of x equals a, right? The other case is x equals -a. Sorry, my pen's a little slow tonight. So 2w minus 3 equals negative 5. And now I'm just going to solve them. That's fine. I'm going to solve them sort of at the same time so I don't have to move my hand as much because I'm lazy. But I get 2w equals 8 and 2w equals negative 2 divided by 2. I get w equals 4 and I get w equals negative 2. Those are the two solutions that are going to work here. And you can go back and check and make sure they do, okay? All right, this one works exactly the same way. You can try it. I have faith in you. All right, let's try the next one. This one is different for sure. I have to do some work first. I have to get to this standard form absolute value of x equals a. I don't have that right now. What I need to do is move this 6 to the other side. So that I get the absolute value of 2c minus 5 equals negative 4. And now I have to think for a second. I know the absolute value of it, doesn't matter what the heck is in here, cannot equal a negative number. Not possible. So right away, I can stop working. My answer is that there is no solution here, okay? You try this one. Works out pretty similarly. Let's try another. This one, all of a sudden it got crazy looking, right? But it's not really as crazy as you think. We're going to do the same things we just did, okay? I want to get to standard form first. So I'm going to move the 7 over. I'm going to get negative 2, absolute value of 2/5 p plus 3 equals negative 12. I can't have the negative 2 hanging out here at the front, but because there's no sign here, that's implied multiplication, which means I can divide it through. So I'm going to get the absolute value of 2/5 p plus 3 equals 6. All right, great. Now I'm at my standard form, absolute value of x equals a. Now I'm going to make my two cases. 2/5 p plus 3 equals 6, and 2/5 p plus 3 equals negative 6. All right, and then I'm going to solve, just like I did before. Just be careful of your math. 2/5 p equals 3. And over on this side, I get 2/5 p equals negative 9. Multiply by the reciprocal, 5/2. All the way around, times 5/2. All right, on this side, I'm going to get, well, 3 times 5 is 15/2. All right, that's one answer. On the other side, I'm going to get p equals 5 times 9 is negative 45/2. Done. That's it. Okay, you don't need to make them decimals. Don't do that. Okay, this is the next one. This works exactly the same way. You should try it. When you get done, you should get a equals 2. Oh, sorry, didn't want to work. And a equals, come on, sorry, there's like this crazy delay. I don't know if the computer's not picking up. There it is. It's not, it doesn't like my finger today. Negative 10/3. Okay, those are the two solutions. Let's try a different case. This is exactly the same thing. Okay, it just has decimals. No one is going to die from this. So I'm going to make it in standard form, minus 6.9 to both sides. I'm going to get 0 equals the absolute value of 4.1 minus p. So I can make my two cases again. But remember, like 0 equals 4.1 minus p, and negative 0 equals 4.1 minus p. 0 and negative 0 are the same basic thing, so I don't even need to worry about that case. I'm going to subtract 4.1 from both sides. And then I'm going to get negative 4.1 equals negative p. So positive p equals 4.1, and it's finished. Okay? All right. The next slide, very, very similar, right? You can do this one. I have faith in you. The answer in this case is going to be x equals negative 1.2. All right. Then we have just a little bit more in this section. So sometimes you get absolute values on both sides. Basically, the idea here is that sometimes I can't get to standard form like this. sometimes I have two sets of absolute values. So my goal in that case is to get absolute value equal to absolute value. Basically implies two cases. Case one is that x equals y. Case two is that x equals negative y. All right? And sometimes whatever is in here in that y, it's got to be negative, whatever is in here. It might just be a number, but it could be a full expression. Okay, so this is a case of that. My two cases here are 2w minus 3 equals 5w plus 1, or 2w minus 3 equals negative the quantity 5w plus 1, not just negative 5w. This has to get distributed. It goes to all the pieces. So on this side, I'm going to combine some terms. I'm going to move the 2w over. I'm going to move the 1 the other way. I'm going to get negative 4 equals 3w. Here, I got to do some work still. 2w minus 3 equals negative 5w minus 1. So I'm going to add 1. I'm going to subtract 2w. I'll do the same process. All right. So I'm going to try to get negative 2 equals negative 7w. Okay, so on this side, I'm going to divide by 3. I get w equals negative 4/3. On this side, I'm going to divide by negative 7. I get w equals 2 over 7. Two negatives make a positive. All right, we didn't die. Everybody survived that. You try this one. Works exactly the same way. Go back and look at the other example if you need to. When you're finished, you should get x equals 4 over 5 and x equals negative 2. If you're stuck, go to the discussion. That's what it's there for. All right, let's try another one. So in this case, I'm going to do my two cases. X minus 4 equals x plus 8. Or x minus 4 equals negative x plus 8. All right, so I'm going to add 4, subtract x. Right row, I get, these guys make 0, these guys make 0. I get 0 equals 12. Well, shoot, that's not right. That's impossible. That's fine. Sometimes that happens. That's no solution for that. So on this one, I'm going to do x minus 4 equals negative x minus 8. I'm going to add x. I'm going to add 4. I'm going to get 2x equals negative 4 divided by 2. X equals negative 2. So in this case, there's only one solution. Okay, that's all right. No big deal. One of the cases didn't work out because it became like this is an impossibility. That's fine. All right, you try this one. In this case, there's also just one solution, and t equals 1/4. All right, that's the end of this section. I will see you in the notes for 1.7.